let's talk about how these sensors work. Okay, so QTI stands for Charge Transfer Infrared. Okay, and this little sensor contains both an IR emitter and an IR receiver. And IR stands for infrared, so it's electromagnetic radiation that's above the red in the spectrum. Okay, so it's basically it's a electromagnetic energy that you can't see, but it's there, and it's what we use to detect. It's essentially heat, okay? But it's really neat because we can generate this pretty easily, and we can build detectors that can see this. And so what you're going to see in here is you're going to see 3 pins, red, white, and black, and you're going to see 2 different circuits that sit within here. What you want to do is you want to wire, like we said, the white to +5, red to pin 2, and then let's do the black to ground, and go ahead and use these cables that are provided. But again, remember, you can't plug them into the servo headers, so use a 3-pin jumper. And then let's think about the way that this works. When we wire +5 and ground to the cables of this little guy, what happens is that you are essentially putting +5 through a resistor through this IR diode to ground. So it's always on, it's always transmitting. Okay, so you can think about 2 separate circuits where the transmitter is just on and it's never going to turn off. So we have no real control over it once we wire it up. The receiver is going to be connected in series with a capacitor and this transistor basically. And the way that this works is that when it sees IR energy, IR radiation, it will allow more current to flow. So it'll cause current to flow. When you are looking at the receiver, you don't care about this resistor and the diode over here. It's just always on, and you can just ignore it. And what we do here is we just concentrate on what's going on right here. The 220 ohm resistor is in series with the IO pin, but it doesn't necessarily impact the circuit. It's just there to kind of limit some current. We're really concerned about this capacitor in series with this IR detector, and this IR detector is going to essentially look like a resistor. Okay, so when it gets IR, it's going to allow more current to flow, which means that its resistance goes down. When it doesn't have IR, it's going to not allow current to flow, and it's going to have a high resistance. So we can essentially get this basically down to an RC circuit. So that's the way that we're going to detect the IR. And we use the fact that IR energy is absorbed by different colors. Okay, so for example, if you put IR energy out into a black surface, the black absorbs all the infrared energy. Okay, so nothing will actually be reflected, but white will reflect it. Okay, so if you have a transmitter, which we do, or an emitter, and it's always on, it's going to be pumping out this IR, and then it will, if you hit a black surface, nothing comes back. If it hits a white surface, it will come back, and luckily we have a receiver or a detector sitting here that will observe it. So since we know we're outputting this IR, we can essentially determine whether the surface right by the sensor is either going to be light or dark. And we use this for things like line following. So if you put like a black piece of electrical tape down on a white floor, you can put the sensor right over it, and you'll be able to detect whether you're on the white part or the dark part, and you can essentially steer to follow the line. Okay, so if you think about, let's look at the case where you're over a black circuit, nothing is being bounced off of the surface and coming back into the detector. And so what will happen is that this little IR transistor right here, it will not have current flow. So there's nothing really flowing. But when you do reflect it, it hits this, and this little phototransistor is going to allow a lot of current to flow. The reason that this is important is because since the sensor itself has a capacitor on it, and so we're limited with what we can do. It's basically designed to essentially look like an RC circuit. So what we really want to do is we want to charge up this capacitor, and then we're going to manually charge it up, and then what we're going to do is we're going to allow it to discharge, and we're going to discharge it in an RC circuit fashion. The capacitor is actually in the circuit itself, so it's this little fella right here. It's this 0.10 microfarad, and the resistor in the circuit is going to be the phototransistor, or the IR transistor. Whenever you have a passive RC circuit, the discharge follows an exponential decay of e to the negative t over RC. Okay, so what's going to happen is that if you have a lot of absorption and there's nothing coming back, this transistor, so you're on a black surface, this transistor right here is going to not allow a lot of current to flow. And so it's going to have a high resistance. So that means the R is big in that exponential decay, and it'll slowly discharge, okay, or slower than normal, okay, with normal being kind of right in between the two. Okay, then if you looked at this situation, you're going to have a lot of IR coming back into the sensor, and this IR transistor is going to have a lot of current flow, meaning that it's essentially its resistance is low, and it's going to have a faster discharge. So what we can do is we can take advantage of that, and we will actually take pin 2 of the Arduino, and we will charge up the capacitor, and we're going to do it by just writing a high to it. And then we will turn that pin from an output to an input, and then we will allow the thing to decay. And the rate at which it decays is going to matter depending on what color of surface is right next to the sensor. And it's pretty awesome because you can see it in real time. So in this situation, we're above white. So everything is being reflected, and notice that it's charged up. We charged for 1 millisecond here, and then all of a sudden you say, okay, go. Well, you're above a white surface, that IR transistor's on, it's pumping, it's got a really quick discharge rate. Over here, you're above a black surface. There's no IR being bounced back into the detector, and so what happens is that IR transistor is not letting current go, so it's got a high resistance, so it has a very slow discharge rate. Now, how do we use that? Well, this is a digital device, and the way that the Arduino works is essentially above 1.4 volts, it reads it as a high, and below 1.4 volts, it reads it as a low. So if you can see this little red line here, that's about at 1.4 volts. And if you think about after we discharge, what if we waited like 1 millisecond and then we read? Okay, so in both of these situations, both of these plots right here, I waited 1 millisecond and then I read. Notice that in the situation where you were above a white surface, it had discharged to a 0 immediately. So it went below that 1.4, and you're at a low. So if you read right there, you'd see a 0. Over here, though, if you're above a black surface and the thing is slowly discharging, it hasn't discharged down to a 0 yet, or to a low yet, and so you would actually read a 1. So that's how we're going to do this. This is the theory of how we're going to do this. Is we're going to create a program, and we're going to essentially charge up the capacitor for just a millisecond, okay? And then what we'll do is we'll turn the pin to an input, and we'll wait a millisecond, and then we'll read from the sensor, and then we'll see what we get. Okay, so let's go ahead and let's do it. Alright, so the first thing I'm going to do here, let me clear this out. First thing I'm going to do is I'm going to start up a new Arduino sketch, and I already have my my sensor on there. Okay, so you can see my sensor right here. Okay, so there's that little fella. And you can see I've got it wired up. I've got my 3-pin header coming in right over here into pin 2. I have an oscilloscope connected to it right here, but I still have my whiskers on there and everything, and then the little baby's down there centered right in the middle. Okay, and then I have a piece of paper I just put a piece of electrical tape on it so we can kind of determine the surface that we're above. Okay, so here's what I want to do. Let's start up a program, and let's fire this baby up. The first thing I'm going to do is let's get our serial monitor on so we can watch what's going on. So I'm going to do a 8600, and then we'll go serial print, line testing QTI sensor. Okay, and then let's delay. We don't even need a delay. We can play a tone since our piezo speaker's on there still. So let's go ahead and play that for, I don't know, half a second, and then delay 500 to let it sit there. And now I'm ready to go. Okay, so what's interesting about when you use this sensor is everything's in a repetitive loop, including the way that you set the pins up, and that's because we're going to be changing between inputs and outputs on pin 2 over and over, and that's perfectly fine, but we're going to put it into a loop. Okay, so the first thing we want to do is we want to turn the IR emitter on for 1 millisecond, and this is going to charge up that capacitor. So the way that you do this is the first thing we have to do is do a pin mode, Pin 2 is where we connected the red of that little sensor, and we're going to make it an output. Okay, and then let's drive a high. So all we do is do digital write pin 2 high, and then we just need to delay, and we're going to delay for 1 millisecond. Okay, and that's going to get ample time for that capacitor to charge up. All right, now here's what we got to do. We're going to turn IR. It's not turn IR emitter on. It's basically charge capacitor. That was way better. Capacitor for 1 millisecond. Okay, the thing's already on. The emitter's already on. Then what we want to do is wait 1 millisecond and let capacitor discharge. And it'll discharge quickly if it's over white. It'll go slowly if it's over black. So what I'm going to do is I'm actually just going to go, okay, pin mode, pin 2 is now in input. And as soon as it flips to an input, it's not driving that capacitor anymore, and we're good to go. And now I just want to delay for 1 millisecond. And then now I want to read it. Okay, read pin 2, and I want to see what's happening out there. And I'm either going to see a high or a low, but remember how we do a read, we need to set up a new variable. And so I'm going to create a variable. It's going to have a type byte, and let's call it sensor 1. And that's my variable. I just made that up. And then I just do a digital read from pin 2, and that's it. I'm done. So now what I'm going to do is let's just print this baby out to the screen and see what happens. So let's do serial.print line, and I'm just going to put sensor 1, and then we'll delay 50 milliseconds, and then do it all again. Okay, so let's go ahead and fire this baby up. Okay, I'm going to go, oh, I skipped my first step that I always do. I just got to save this. So let's go back and save this into our working directory that we have. So desktop, and I'm doing Arduino, and let's call this QTI test 1. Okay, all right, and then let's go ahead and fire this up. I'll bring over the serial monitor while we're sitting here. Okay, so there it goes. All right, and now it's writing. Okay, and so I come over to here, and one of the things that I'm going to see is I've got my paper. It's actually hitting this brown on the desk, and it sees a 0. Watch what happens when I put it on white, nothing. But now I'm going to slide the black over it, and watch the 1s appear on the serial monitor. So as soon as I go over the black, look at that, it's changing to a 1. And then as I slide across it, it changed to a 0. What's even cooler is look at this oscilloscope shot. So I happen to have a portable oscilloscope hooked up on this thing, and let me put it so that you can see the serial monitor. And I'll put the camera over here. Look at what happens when I move from white. So this is the fast discharge, and then it's going to go, here's the long discharge on black, and then back to the white discharge. And what's kind of cool is you can put this marker where it's about at 1.4, and you can see that it's quickly discharging right there. And then as I go over to here, it goes long discharge, long discharge right there. And so this is it. It's working. We are able to detect whether we are on a light or dark surface, and we are just looking at it as a digital. You could conceivably look at the discharge rate and try to determine a particular color, because one thing you'll notice is, watch when I go from a white to like a brown, it reflected a little bit more, but it wasn't like a white does, or white reflects everything. Brown reflected some stuff, but it kept some stuff. And so you could actually do a full-blown color detector. Okay, so that's it. Go ahead and make sure that your sensor is on there, and then enter that sketch in there and play around with actually getting this thing to actually work. Okay, good luck.